video we will discuss about the stack. There is some methods given by C++, like it's a part of STL. C++, we are having some defined name which is known as a stack. So that means there will be some default method which is going to be provided by C++. So exactly how this is going to help you while solving the problems, that thing I will get you with. First, we will be letting to know basic of stacks, where we can apply this stack, and some important methods which is regularly being used, regressively being used by the whenever we are dealing with a stack. Okay, thereafter we will solve a simple problem which will make your thinking process with stack that will be on a higher level. So let's get into this. So first we will get to know the definition, what it is a stack. Stack is something which is telling like you have some elements which is going to, suppose, just think like in a container. Okay, you're having a container and you want to push some element into that, then what order it is going to follow. That is basically in difference between queue and stack. Okay, so here in stack it will tell whatever element it is coming in the container, then it will be following a property of first in last out. Okay, or last in first out, the same way. Okay, means the element which is coming in the container first, it will be coming out from that in the last. Like it is happening, you are putting an element on top of the last element. Okay, and whenever you are trying to access the element, that will be from the top. Okay, so suppose, like what I mean is, suppose you are sending the last, this is the last element, and now again you are adding one more element, suppose them name as last 4. So what this is going to follow, this is a example of stack where you can, as soon as you trying to access the element, you will access the element from the top, right? So what element you can see at the top? I can see that is L_4. This is the one which we have inserted at the end, right? So you can say we have inserted this thing at the end, or you can say last, means it has entered at the last, means last in, but you have accessed this element very first, so last in first out. Or you can say the element which has entered first, so I can say this is the element which is known as last, but it will get out from this container at the very end. First we are going to access this one, then we will access 3, then 2. As soon as this all is being done, then we are going to access the last, means this will be the end element or last element, right? So I can refer, this one has entered first, so first in last out, right? Last in first out or first in last out, both are referred as a stack. If somehow you just going to saw any objective type question which is going to follow the property of LIFO or FILO, that is LIFO, last in first out, or FILO FILO, that is first in last out, that is nothing but stack. And for Q, that is first in first out or last in last out. Okay, hope so this makes your understanding for this stack much better. We will discuss some major functionality which is going to be used very frequently. Okay, so there is some functions, I will write it down here. First, accessing the top element with the keyword called top. We are going to insert the element with the help of push. Just we are going to check the stack, is that empty or not, is that containing any element or not, and we can check the size of the stack till now, whatever it is. There is one more method called swap, which is not that much use. Swap is going to be used for whenever you are having two stack and you want to swap the element in between each other. Okay, so let's get in touch with all these functionalities. So let me describe a stack as ST. Let's insert some element. Let me take dynamic data. We are trying to insert some elements, that is count of 5. Okay, let's insert it. We are using this push method to insert an element. Let's insert some random data which is going to be taken by the user. Okay, provide this input. I'm providing A, B, C, D and E. It's 5 elements we have passed, and it will insert all these elements. As this is a stack or queue, we cannot access any element at any random pointer. Okay, so we have to access element one by one, and each and every element we have to access only from the top. So if we want the accessing all the element, then we have to remove the element from the top so that we can access the next element. Okay, so we are going to use that. So for that, what I will be telling, okay, just go until and unless my stack is filled with some element. So it's telling is my stack is empty. Let's first we'll see some more things. Let's try to check what is this empty is returning. Okay, we have done with everything. Let me run this. Okay, you can see this is telling st.empty. It's 0, means it is false. Okay, so let's see if we are using not operator, means what it will tell, is it empty or not. If it is empty, then it will just change it, means if it is empty or not, just we are trying to check with that, just we are using not operator. So it is telling, okay, right now you can say, yeah, this stack is not empty. Okay, so in the same way I will apply this property here, and just will try to get the element at the top, what it is. Now as we are trying to access the next element, we need to remove the top element, else what it will happen, it will try to access the first element from the top again with the method of top. Okay, let me do one more thing with keyword top. Let's see, you are getting E, right? So first we have inserted A, then B, then C, then D, then E. So at the end we have inserted E, that's why it is coming out as a first element. As soon as whatever number of time you are trying to get the top element, you will get this E only. Let's see. See, you are getting E, but I need to access this D element when we are trying to get the next time top. So this is telling you haven't accessed this one, you are trying to access only this top element. If I trying to access this D, then I need to delete this E. Okay, so that thing I will show you in this loop. Just check it how we are going to achieve that. There is one method called pop. I haven't mentioned. Okay, there is method called pop that we will be using here. Just see. Okay, first we got E, then D, then C, then B, then A. After getting A, what it will happen, it will tell st.empty, it will tell, yeah, true. It is true, means as soon as we have deleted all the element, means stack is empty. At that time this stack.empty, till here it will tell true, and we are using not operator, so it will tell, okay, not of true means it is false, so while false, so it getting exit, so exiting from the loop. Let's see what we are getting after this. Means is a, let me change the line. See what we are getting, 1, means it is telling is our stack empty. It is telling, yeah, it is empty. We got to know about top, we got to know about push, we got to know about empty. We haven't seen this size. We'll see that what it is. So here we'll try to get the size method as well. So size will nothing, it is going to tell how many elements are there available in your stack for now. So it is telling 5. Okay, after each time let's see what we are trying to get. See, first its size was 5. Okay, thereafter we have removed, oh wait, we have done, okay, it is empty. Yeah, see, earlier its size was 5 for initial stage. After deleting this E, we are getting size of 4. After deleting D, 3. After deleting C, 2. As like that, after deleting A, we are getting size of 0. That's why it's getting exited. Okay, so that's Done. Now you can just use one more stack and you just swap the element. That's similar how we do a number swap. Okay, let me do one more thing. st1 the same way I will try to push the element in st1 so that it should not get more time. We are using ch, so we are having this st1 as well. So now if we are trying to, okay, but this will be having, okay, let me do one more thing. Let me insert some more element in st1. Okay, so what will happen here? We are having 6 element in st1. Okay, but we will try to swap first. Let's swap this stack st and st1. Before that, we are not interested now in order to get these things. Okay, just we are trying to swap this element. Now try to access this stack. You will see you will be getting r as well in the stack, st. Let's see. See, you are getting r at the top, but in this st we haven't added this r. It is in st1. Why we are getting? Because we have swapped. I have picked one question for this stack. Okay, so this problem I have picked, it's really one of the good question which will help you to understand this stack very well. Okay, so what this question is telling: given an array of integer temperature represent the daily temperature, returns an array answer such that answer I is the number of day you have to wait for the ith day to get a warmer temperature. If there is no future day for which it is possible, keep the answer of I equals to 0 instead. What this problem is telling, like for any day, any instance day I, whatever temperature is there for today, how many number of day you have to wait for the next day when your temperature, that day temperature is going to be warmer than today. Okay, that difference it needs. Suppose there is a day I, after that there is no any day which is going to be warmer. Suppose today's temperature is 27 and only array is given for some day, but after today there is no such day which having temperature greater than today. So at that time you have to put value 0. Okay, so how we are going to solve this question? Just you can pause the video and just think it. After that you can restart this one. I will let you know. Let's deep dive into the approach how we are going to deal with this. So first we have to think like, okay, for any day can we get any another day which is going to tell me, okay, this is the one which is greater temperature. There is another way to solving without a stack, which is pretty simple. Like you can just triangle loop for any ith instance. You will start another loop, inner loop you can say, which is going to start from I plus 1 till end. Okay, that is the brute force, which is big of n square, ending up to the window of big of n square, right? So that is not which I am trying to deal with today, because we are going to intended to solve it with the help of stack. So I will let you know, just think about the stack. So if I am going to push element 73 first, then as soon as any element which is coming in the stack which is greater than any element which is coming, and that element is greater than the top element of this stack, means what this means is I am the element which is coming, I am someone which is coming as a greater element from your stack, from the top of the stack. What this means is I am the day who is warmer than you. Okay, and just think any element which is on the top of the stack is the someone which is either equal to all the element which is available in the stack, or it is smaller than that. What I mean to say is any element in the top, suppose it is T1, then element T2, then element T3, then element T4. It is element in this stack. Okay, so this is telling I am this someone T4 which is at the top, then I will be T1 is such that it is either less than or equal to T3. T3 is such that it is less than or equal to T2, and T2 is such that it is less than or equal to T1. If it is not, suppose what I am telling, just think here, if T1 which is greater than any element, that is T4 for now. If it is, then I will tell okay, I am boss of all of you element. What this means is T1 is the temperature which is greater than all these, means T5 is the temperature which is greater than all these elements because it is greater than T4, and T4 is telling I am someone who is either less than or equal to. Who is either less than or equal to means T5 is the temperature which is warmer for all the element. Okay, at that time, any instance, if an element is coming and is greater than the top of the stack, then I can say okay, just remove all the element and tell them I am that element for which you are searching. Okay, just next element is the T5 for which this T5 is warmer than everyone. Okay, let's solve this problem in that way. So for the first element, anyhow the first temperature will be the one which we cannot tell anything, because 73 if we are referring, then 73 in itself is everything. Okay, so for the first element we are going to directly push the element into the stack. So for this thing you can see okay, at least one element we are getting, so blindly we can insert. So let's use a stack with the name of ST. Let's push the element. Okay, what we are trying to push? We are trying to push the index. Okay, we will be accessing the element with the index, because if we are trying to get the element, okay, so it's telling okay T5 which is coming, suppose is greater than T4. Okay, we are getting the element but we don't know the index of that element. But if we know the index of the element, then we can get the element, right? So we are trying to insert the index rather than inserting the value. You can insert a pair where first will be the index, second will be the value. That don't make sense, because we are having this vector which is going to tell us the value for a particular index. So let's try. So I will try from index 1 as index 0 we are done. Okay, here we are going to use this temperature vector as any element which is coming just greater than the top of the stack, then we are going to pop all the element, right? So I will tell okay, while this ith element, if I am the element which is greater than the temperature, whatever it is there on the top of the stack, if it is, then I can say okay, let's go and remove that element. What I mean is remove all the element whatever it is in the stack, right? But what we need, whatever it is at the top for now. Okay, this is the index, right? So what I am telling, okay, whatever this index is there, any element, whoever it is there at this index in this temperature vector, just make the changes. Means if we are removing this T3, then I can say okay, T3, for the T3 this T5 is the answer, right? For T2 T5 is the answer, for T1 T5 is the answer. What I need is whatever number of the I can take from T1 to T5, that is nothing but T5 minus T1. This is the index, right? So I can say okay, fine, then for the temperature of ST dot top, what it would be, that is going to be current element minus I, means that is ST dot top, this index is the one who is warmer, right? And the current element which is nothing but I. That's it, we have solved. But there will be one issue, like if we are trying to access the top element, but suppose there is no element available in our stack, then what will happen? At that time we will just tell okay, if it is empty or not. If it is not empty, then only you have to access. Okay, means till this it's fine. But suppose there is one more scenario they have told, if there is no future day for which it is possible, okay, then for that you have to put the answer 0. Okay, what this means is we are getting any element which is greater than the top of the stack, right? But right now I am not getting any element which is greater than the top of the stack, but instead there is some element. Let's take this example. Okay, so for the first time this 73 is going to be inserted in this stack, then 74 is trying to insert into the stack. What it is telling, I can see 73. So for 73 I am the someone who is the answer. Okay, I will compute and put the change the temperature. Okay, means number of day, whatever it will be. Now 75 is trying to come, we have inserted 74. Now 75 is trying to come. Okay, so at that time what it will telling, okay, I am the someone who is greater than 74, correct. So it will remove that 74 and it will insert 75. Again 71 is coming, but 71 is not the eligible candidate. 69 is not the eligible candidate because 69 is less than 71. Less than or equal to, it is not eligible. But as soon as 72 is coming, it is telling I am the someone who is greater than till this element. So it will pop all these two elements, right? Thereafter it is coming 76. It will tell, okay, I am the someone who is greater than these two elements. So it will tell, okay, I am warmer temperature for 75 and 72. Thereafter it is coming 73. 73 is telling, no, I am not the eligible candidate to do this. So for now my stack is containing these two elements which don't have any future dates for their warmer temperature. So for these two things my answer would be 0 and 0, right? How we are going to compute this? I will tell, okay, until and unless my stack is not empty, means I will tell, okay, these two elements will be left, means just put that value is to be 0, right? So what, yeah, we having st and we are going to check it, then we'll tell temperature. Sorry, let's copy this, take this here. Okay, so what we are going to tell, whatever element it is at the top, I will tell, okay, for that index value is 0 and let that to be popped. Okay, and one more thing, as we are trying to remove all the element, thereafter we are inserting this thing as well, right? Earlier it was 74, then we are telling, okay, 73, then as soon as 74 is coming, we are deleting 73 or whatever element it is earlier smaller, right? For suppose for 75 or some element like 72 here. Okay, so we are trying to remove this 69 and 71, then we are inserting this 72 as well, right? So we are trying to remove all the element which is either less than or equal to, means if I am the guy who is greater than, then we are removing all the element. At the end of the day we are inserting as well, right? So where we are inserting in this stack, correct, the way how we have inserted here first element, in the same way we are going to insert this ith index, else there will be no element inserted in this stack. Sorry. So we are done, everything is done. Let's return it. We have done something wrong. Wait, I guess we have subtracted a wrong value. Okay, oh sorry, this should be I minus st dot top, right? Because st dot top will be the something which is element before this stack dot top, right? Whatever we are storing index at this point, so this I is the one which is greater, and whatever element it will be in the stack, that will be before I, right? So we were doing that wrong. Let's try it. Yeah, it's passing. Let's see, are we able to submit it or not? Yeah, we are able to submit this problem. So here, what is the time complexity? Let's see the time complexity. For the time complexity, we can think like anyhow we are running for the whole element, right? For the temperature dot size, inside this it is not for compulsory all the time that we are reiterating each and every element once again. Means overall we can straightforward till this, it's more or less a linear time complexity, right? Just we are iterating this temperature, that's it, and depending on that sometimes we are just trying to access some more element. So more or less it is a linear time complexity. So we can say it is big O of n. Okay, big of n time complexity. Okay, so that's stack. It is going to help you understanding this stack, as well as this problem is one of the really good problem. And you can see this is nothing but it's a standard problem called next greater element. There is a standard problem called next greater element. Okay, so this is nothing but a version of next greater element. Just a little changes happen. Count, tell me the difference of that, that's it. Nothing. Tell me the difference of number of that, that's it. Nothing more than this. So this is nothing but a next greater element. Same problem you can solve next smaller problem than parenthesis. There is a problem called parenthesis balance parenthesis. Okay, so that's really very important. It's one of the good problem I can say in online assessment round, in the interview round. I personally have faced this problem in 2 times. One is in Amazon online assessment round, and once in my personal interview, one-to-one interview. I have faced this problem. So I would recommend just go ahead and solve this problem. It's an easy problem. It's not tough. It's easy and stack. You just go on lead code and filter the problem with easy and stack. You will get this problem. So that's it from this video. We will meet in the next video.